Hello friends, welcome to 30 Minutes Learning. Today we'll talk about Docker, its components, architecture, and how it works. Stay with me to understand about Docker. Please give this video a thumbs up and subscribe to 30 Minutes Learning for more such tech videos. Let's get started. Docker is an open platform for developing, shipping, and running applications. Docker enables you to separate your applications from your infrastructure so you can deliver software quickly. You can significantly reduce the delay between writing code and running it in production. It is based on a methodology of build once and ship. Docker allows you to create an image, run image as a container. Docker is a lightweight, fast, and provides a viable, cost-effective alternative to hypervisor-based virtual machines. So you can use more of your compute capacity to achieve your business goals. And since we can deploy multiple instances of an application as a container built from an image, this avoids a single point of failure of your application. However, we need to add few more extras, but as a starting point, this helps a lot. Before we deep dive into what are the components and how Docker work, let's first understand what is image. Image is a read-only template with instructions for creating a Docker container. Often, an image is based on another image with some additional customization. Let's take an example of a Spring Boot application which is to be deployed in an environment. We will use the base image or a read-only template of the image. In this case, it would be OpenJDK, and pack the executable file with the required instruction to start the application as image. Now let's understand what is a container. A container is a runnable instance of an image. You can create, start, stop, move, or delete a container using the Docker CLI. You can start multiple containers from the same image. You can connect a container to one or more networks, attach storage to it, or even create a new image based on its current state. You can run more containers on a given hardware combination than if you were using virtual machines. Let's understand how a virtual machine is different from Docker. On the left side, you see a virtual machine setup, and on the right side, you see a Docker setup. In both the setup, we need to have a host operating system, and in the virtual machine, we need to have a hypervisor, and hypervisor will support the respective virtual machines, which will have its own operating system, and again the libraries and the bin files required to support the execution of the application and the application itself. While on the other hand, Docker gives us the minimal setup required. First of all, we have the host OS, and then we have a Docker engine in place, and Docker engine will host the respective minimal required libraries or the bins to support the application and the actual application itself to achieve what we want to as part of the application process. Another benefit we get from Docker over virtual machine. Since virtual machine has guest operating system, it has its own memory requirement and CPU requirement over and above the application overhead. But in Docker, since it do not have the actual or the complete operating system, it has only the files required to support an application. That is why it is more faster, and you can run more Docker containers than you would have run a virtual machine with the same hardware configuration. Now let's talk about the Docker engine. Docker engine is a client-server application which has three components: server, REST API, and command line interface or CLI. Server, which is a type of a long-running program, and we call it Docker daemon. Next is a REST API, which signifies interfaces that program can use to talk to the daemon and instruct it what to do. And the last we have is command line interface, which we call it as a client. CLI uses Docker REST API to control or interact with Docker daemon through direct CLI commands. Docker daemon is the one which creates, manages Docker objects such as image and container, networks, services, and volumes. A program issuing a Docker command using a CLI will interact with the REST API, and the REST API will interact with Docker daemon, which do the actual job of managing the Docker objects. Understand the Docker architecture. Docker architecture has three components: client, Docker host, and registry. Let's first understand about each component. First, we have Docker daemon. We have already spoken about it. Docker daemon is the one who is listening to all the Docker API requests and manages the Docker objects. Docker registry is a place where all the Docker images are stored. Docker Hub is a public registry that anyone can use. and Docker is configured to look for images on Docker Hub by default. You can even run your own private registry within your firewall. And the last component in the architecture is Docker client. The Docker client is the primary way that many Docker users interact with Docker. When you use commands such as docker run, the client sends these commands to Docker daemon. The Docker command uses Docker API, and the client can communicate with more than one daemon. Now we know what these components are in this Docker architecture. Let's understand more about this architecture. Docker uses a client-server architecture. The Docker client talks to the Docker daemon, which does the heavy lifting of building, running, and distributing your Docker containers. The Docker client and daemon can run on the same system, or you can connect a Docker client to a remote Docker daemon. A Docker client and Docker daemon communicate using REST API. With the community distribution that we get with Windows and Mac, we get Docker client and the server as one package. With the help of Docker Toolbox, we can install a Docker machine which the client can be configured to connect to. And we will learn about these subsequent discussions where we talk more about the commands and how they work. And those discussions will be taken care in the next sessions. Let's understand the flow whenever a client uses or issues a command. I executed a command docker run jboss/wildfly. jboss/wildfly is a Docker image available in Docker Hub. So when a client issues this command to Docker daemon, it first checks if that image is available locally. If it is not, it pulls out the image from registry and keeps a copy of the image locally. And from that image, it creates a container and that gives you the output. And for jboss/wildfly, it will start a jboss server. And the default port for that would be 8080. However, we need to do more configuration so that we can communicate from local system to the Docker container, because by default we do not get any communication between the two. In the next discussion, we will talk about how to set up Docker machine, work with the Docker CLI, like working with images, running a container, building custom images, multi-container setup, and many more. Thank you for staying with me on this discussion on Docker. Please like the video and subscribe to my channel for more videos.